Hi students, today we're looking at limit properties. These are some of the things that we've been using already, and we're just kind of formalizing these today. Uh, Being able to formalize these in this way means that any limits that we do throughout the year, of which we're going to have several special types of limits that we'll see, we can apply these same properties to as long as whatever the new math is doesn't kind of break that. As always, there's some Khan Academy stuff that'll be attached to this that you will see on your version of this. All right. I just wanted to state that the stuff that's here, hopefully you've been practicing or trying to make some sense of. In terms of our goal here is to understand the different ways that we can write these things and how they end up looking as terms of values. I'm going to pause now. I'm going to fill out the answers, and then I'm going to spend a couple minutes talking about it, but not go through each one separately. Okay, lots of answers have been filled in here. The big idea is that based on the operations that we're doing here, we've got addition, subtraction, multiplication, division. We've got multiplying by a scalar. We've got raising to a power, both a whole power and a fractional power, half a radical. In all of these cases, we can talk about the limits before we're combining or afterwards. One of the things that we've been doing kind of intuitively is plugging numbers into polynomials that are different functions being added together. And that's really what this is showing that we can do. And these are the properties that, again, we've already been using. We're not going to define them really any further or talk anything about where these come from in terms of how we're going to use them. All right. So again, we mentioned the stuff that we see at the bottom before, where we're talking about two graphs. There was an issue with my composition graph, so I'm going to use this as a way to kind of get around that. I'm going to pause again, fill in the answers for the top, and fill in the answers for the bottom, and then briefly talk about things. All right, the ones up top should be pretty straightforward. Those are all about plugging things in. You're given each of these values and kind of figuring out where they go. The ones in the bottom get a little bit weird. At the beginning, they're kind of okay. We've got one where we've got to consider the limits. That's at a point that works pretty well for us for limits, so we don't have to really worry about that. Then we begin to have some things that are a little bit more questionable. We've got a couple things that are does not exist. B is a really good example of that, because if we take the limits of both of these from the left, which would be 2 times 1 on, sorry, I'm approaching the wrong thing here, 2 times 1, and then on this side, 3 times 2. The negative 4 we get from that is different than if we had approached from the right side. We get negative 1. It's because these two limits don't exist that we end up with a does not, or sorry, because these two limits are not equal, we end up with does not exist for that one. And then I really want to talk about f. This is a mess. It's going to be a mess in your head, and that's okay. There's a theorem that talks about that the limit of a composition is equal to the limit of the inside function if our outside function is continuous at the place that we're going to inspect. We're going to find that's going to be 2. This means this particular problem does not satisfy that theorem, which we can use most of the time otherwise. So what we've really got to do is take a look at, again, the limit of the inside as x approaches 1 from the left. Cool. We're approaching 2. That's where that 2 comes from. And the other thing I'd like you to think about is the outputs here. As we get closer and closer to 2, the outputs are coming from below. So they're coming from, in the y direction, kind of the left side of things. That's why we can use a left limit on our outside function, and why we get the left limit of 2 instead of f of 2, which is not the same value at this particular problem. It's okay if your brain does not process that. I have to reprocess that every year because I always kind of forget the reasoning for how to get there.